Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Caged Clones by Rocky Rower. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that every row, column, and designated 9-cell region, which is a box in this case, contains the digits 1 through 9 once each. Each cage must appear cloned somewhere in box 9 without rotations or reflections. All cages marked with X must have the same total to be deduced by the solver. Okay. So that means whatever has an X in the corner, it has to have the sum of its digits in the cage adding up to X. And each of the cages in these cells must be somewhere in box 9. And it cannot be rotated. So, for example, this cell, this could be like a cell here. It could be here, it could be here, here. So these are the possibilities. It could be here. It could be here. It could be here. Or it could be here. You cannot rotate it. You cannot reflect it. So it cannot be something like this. That's the reason why those are the only 4 possibilities for this cage here. And each of the cages, again, must appear in box 9 in some way. Yeah, that's all we have about cages. Cells separated by a gray dot must either be consecutive or have a 2-to-1 ratio. So this is like a combination Kropke dot, where basically it could act like a white dot, where if this was, say, 6, this would have to be 5 or 7. Or it could be a black dot, where if this is 6, then this would have to be 3. So if this were a 6, this would have to be 3, 5, or 7 here to either be in a 1-to-2 ratio with the 6 or be consecutive with the 6. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. Each of these cages have to appear in box 9. We have 2 pairs adding up to 9. Or not 9, X. Apologies. But they all have to appear in box 9. Obviously, these are going to be different cells. These are going to be different cells. Same with these and these. Sorry, different digits. Now, the thing is, since this adds up to X, this adds up to, we know these 3 add up to X, so it's at least 6 is the sum of X. I think it has to be 9. Because we have 2 X's here, adding up to whatever the sum is. This adds up to whatever the sum is. These also add up to the sum. But without reflection or rotation, that means this has to be somewhere here, going like this, adding up to X. And it can, actually, this, we know this one specifically cannot appear in any of these, because these would have to be the same digit as that. So as the yellow, it would have to be something, one of these, right? It has to be this pair, or this pair. Same with this, right? this is somewhere in this. It cannot be this, this, or this. It must be one of these sets here. But we know these two are distinctly adding up to x. These two must be distinctly adding up to x because it cannot be the same as these or this or this because there's no rotation or there's no rotation or reflection allowed. So therefore these two are different digits than these. It must be different digits than these and these because that way you cannot have you just can't have it adding if you try to have a same digit in one of these as this and this, the problem is we know there's a vertical set adding up to this x, and if it's the same digit as one of these, it would also have to be in the same pairing, right? So these have to be unique numbers here, essentially. And since these are all unique numbers, they must be 1 through 8, which means x must be 9. Interesting. So this adds up to 9 also. The green can be pretty much anywhere. The yellow is limited to these. The oranges are limited to these. What is this one? Gray's not good. Let's make it blue. So the blue again can be here. It can be here, here, or here. Huh. If blue is here, that's not going to work. Because this cell cannot add up to 9 with these two or these two because it's all blue. So this can never be blue here. What about these? This could add up to 9, 9, and 9. That works. It's blue here, 9, 9, and one of these. This pair cannot be any of these. It has to be one of these sets. Okay, so whatever's here must be in one of these cells. So it has to be one of those 3. This yellow is one of those 3, so it must be one of those 3. This orange is one of those 3, so it has to be over here. This orange is one of these 3, so it has to be one of these 3 there. This has to be 9, because it cannot be green, cannot be orange, cannot be yellow, and cannot be pink. And those are all unique digits. So we have green and orange here, guaranteed. And this is yellow or pink here. Interesting. So this combination Okay. So this red is here, and then it matches one of these three. This red is one of these three, and then matches one of these three. Okay, that's not that helpful. Let's see. What else can we figure out? Again, each of these blues has to be somewhere here. Interesting. This set of digits, it could add up to 9. So it could be this exact same as this blue. We don't know. If it's not, though... Huh. That's interesting. What happens if it's not? I guess it's possible. This obviously can't be 9. If this is 9, that eliminates possibilities for here, for blue, for here, and here for blue. So obviously it can't be 9 here. But these could be, right? So 9 is one of these 8 digits. 8 cells. That's not that helpful. Mm -hmm. 9 could be here, 9 could be here, 9 could be here. Hmm. This is the last one that's going horizontal. We don't... It could add up to 9. We don't know for certain, though. Okay. Hmm. This set obviously does not contain a 9. Huh. What does that mean? Hmm. I'm not sure. Hmm. Obviously, this could be the same as yellow or pink. It could be completely two different numbers, not adding up to 9. We just don't have a guarantee, really. Oh, interesting. Red doesn't necessarily need to add up to 9. Hmm. Hmm. Okay. So these obviously add up to 9. So they cannot, as a pair, ever add up to 9. Hmm. Which means they must be with some other pair adding up to 9. Sorry, with another single digit adding as a pair adding up to 9. So if you had blue, blue, blue here, then this would be one pair. This would be one pair, and this could go here or it could go here. Okay. Huh. What does that tell us? I'm not really sure. I don't know if it tells us anything, really. Um, Again, whatever's here is here, then it must be here. Whatever's here must be here, and then here. Hmm. This is the same as this, which is the same as that. This is the same as one of these three, which is the same as one of those three. Right, so if it's blue, 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 we know this is a set adding up to 9. This adds up to 9. And then either this or this adds up to 9. We're not sure. Hmm. What does that mean, though? Hmm. 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 I'm not really certain what this means. Oh, interesting. Each of these three digits in the blue, none of them can be the same as this digit. And the reason is these two see that digit by normal Sudoku, but this digit, if this were the same digit, if these were the same digits, then in box 9, there would have to be a cage which clones to both this and this. And then that digit would have this adding up to, say it was here, it would have these two adding up to 9, but then these three would also add up to 9. So none of these three digits can be the same as this one. They all three, though, could be any of those, right? Hmm. So this digit is not the same as either of these two, but it could be here and it could be any of these. That's. Huh. Okay. What else do we have? Okay, if it's blue here, that means this goes up that way. Yeah, maybe we should figure out what the blue possibilities are like. Let's clear out the coloring here. So say we had blue here. That means this goes that way. It cannot be yellow. This obviously can't be yellow. So this would have to go this way. Could be orange. So orange would not be here. It would have to be either here or here. Well, it can't be here. Okay, that's interesting. So if blue's here, where's orange? Again, this cell goes up that way, so this can't be orange. None of these pairs here can be orange because they would be the same digit as that, and this would be the same digit as that. So then this would have to be an orange here, which means this cannot be orange. This would be green. This would go up here. This would be here or here. We're not sure which. This can't be yellow. So where's yellow in this box? Yellow can't be here. It cannot be any of these. So it would have to be here. So this would be orange. That would be yellow. Red could fit any of these technically. This would be 1. Pink adding up to 9. So this could not add up to 9 because this adds up to 9 here. So this would, one of these would be pink. We're not sure which. And then this would have to be 9. Interesting. So this would be yellow. One of these would be pink. We don't know what the others would be. So that's what happens if that's blue. If this is blue, this has to go that way. This must go that way and cannot be yellow. Yellow cannot go here. Why did we know enough about this? So yellow, this has to go that way. This has to go that way. So yellow cannot go down here. Yellow has to be here. Okay. So what happens if this is blue? If this is blue, this must go that way. This must go that way. So we have yellow either here or here. And neither of these can be orange then, right? If yellow's here, orange can't be here, here, or here. It's okay. Again, if we have blue here, this is yellow. Orange has to be here. So this has to be an orange pair. And pink is one of these two. Oh, green has to go somewhere. Oh. That's problematic. Because this has to go up and this has to go up. And then this is 9. But there's no possibility for green with 2 greens adding up to 9. Because again, these are all unique. So this cannot be blue. Then that way. And I think this can't be blue either because of the same problem. This must go this way. This must go this way. Where's orange? Where's yellow? Yellow cannot go here, so it can't be this. It's either here or here. Since yellow's here or here, that means this is orange. So again, if we have blue going here, yellow has to go here. Because this must go up, this must go side. Yellow can no longer be, can't be here, can't be here, can't be here. So it can't be here, it can't be here, because this goes that way. So this doesn't add up to 9. And this doesn't add up to 9 because it's part of blue. So then this must go that way. This must go up, this must go up. So orange is here. But then where's green? It can't be anywhere. This goes up, this goes up, this goes up, and that's a 9. So we don't have a green adding up to 9 going horizontally. What if we have blue here? Yellow, this goes this way, this goes this way. So yellow's one of these two. And since if yellow's, this can't be orange, this can't be orange, and this can't be orange. Since yellow's here or here, orange can't be either of these, so this must be orange here. This goes down, cannot be yellow. It could be pink. But say we had yellow going down here. Green does not have a way to become adding up in a cage in box 9 then. So yellow has to be here. This goes down, which forces green to be there. And then this would be pink. And then this would be 9, but that's not possible. Because of... it's not in blue, right? This adds up to 9. So that doesn't work either. Therefore, we know this has to be blue. Yellow cannot be here, cannot be here, cannot be here. Orange cannot be here, here, or so orange is one of these sets. Yellow, again, is one of these sets and cannot be this one. So yellow is one of these two or here. So we're guaranteed these are all low digits. Again, these three cannot be pink with that, but it could be pink here, potentially. Okay, what happens if, say we go that way. If we go this way, the problem is we don't have a way of getting multiple ones going this way, right? If this is going up, these can't go adding up to 9. These can't be 9. These can't be 9. These can't be 9. Well, we know guaranteed these can't add up to 9. So if we tried orange that way, I think... no, that has the same problem. What the? Okay. How does that work then? Right, if we go this way, this must add up to 9 with either here or here. But I don't think that works. Right, if it goes here, we need 2 in a row horizontally adding up to 9, and I don't think that's possible in any way. If we go here, we need 2 vertically that add up to 9. And this already adds up to 9. So these can't add up to 9. This can't add up to 9. This can't add up to 9. This can't add up to 9. And then therefore that wouldn't work. So I don't think it can be that one then here. And I think we've proven this one doesn't work. Right? This can't be yellow. This can't be yellow. No yellow, no yellow, no yellow. This goes this way, and this goes that way. So the yellow has to go here. This goes this way, this goes this way, that goes up, but then we don't have two horizontals here. But I guess it has to go that way then? Yellow can't go here, here, or here. The problem is we ran into the if this is orange, right? Or if this is yellow. Because this one has to go down to add up to 9. Because we have all the unique digits here, right? These can never add up with another digit to add up to 9, and they have to be somewhere in box 9 as cloned without repeat, without rotation, or reflection. So it's really, yeah, how do you fit this in? Because we know all of these digits are less than 9. Ugh. This is not looking good. I mean, I'm not sure what exactly I'm doing wrong here. So maybe it does have to go this way? No, this doesn't have... This doesn't add up to 9, which it must, right? This seems the most promising, but then the problem becomes... So this goes that way. This goes that way. One, two. You can't have a vertical and a horizontal unless that is the 9. But that can't be the 9 because it's blue. What's going on? What's the logic behind this then? We tried going this way, but then the problem is same problem, right? This goes up or left. Oh, wait, I think that does work. Yeah, so I think these were disproven. This one, where's the... This has to go that way, this has to go this way, but yellow cannot be here, here, or here. Yellow can't be here, yellow can't be here because these are adding up to 9, so this is yellow. Orange has to be... This is vertical, that's vertical, this is orange, and that's not possible. And then we have this, where the only way you can have this situation is if this is the 9 in the middle to have the both horizontals and verticals. So that doesn't work. So it must be this way. We have to have 2 horizontals and 2 verticals. This is always going to be horizontal. This is always going to be vertical. And does that work? No. Yeah, the problem... Yeah, how do you essentially get these pink, yellow, and greens in this box with fitting the blue in? That's really the question. Because one has to be vertical adding up to 9. One has to be a horizontal adding up to 9. Sorry, there has to be 2 verticals and 2 horizontals adding up to 9, and all of the blues must be part of those. So these are all blues. You have one going this way, one going this way. If this goes horizontal, this can't be, if this goes vertical, this can't be horizontal. If this goes horizontal, this can't be vertical. So you have that problem. Same with this, right? This goes definitely horizontally. This is vertical. This can be either, if this is horizontal, we have another horizontal width. So we have 3 horizontals supposedly adding up to 9, which doesn't work. So that doesn't work. This is the only one that kind of works, but then this can't go horizontally or vertically to add up to 9. And it must be in box 9. So then that leaves just this. But then this has the same problem, right? This must be horizontal. This must be vertical. And the problem is, so say we had this horizontal, this vertical. If this goes vertical, then this has to be vertical here. If this is horizontal, then this must be horizontal here. Or if we go this way, same problem, right? This goes vertical, that means this must be vertical here. If this is horizontal, that means this must be horizontal here. So we keep running into the same problem. And if we try going this way, horizontal and vertical here, same problem, right? That's not good. What are we missing? Hmm. Ugh. What is this? I mean, yeah, the problem is the only way to get this sort of situation then. Oh. I'm not sure, yeah, how else you can do this. It almost, yeah, it basically says that we can't do that, right? And 9 has to be the middle one, right, to do that. So we say we have an orange here, a vertical here, so this would be, I guess, the pink. That would make this green. This would be yellow. And that's the only way you can really get that way. But the problem is that then you don't have the blue working correctly, right? Adding up to 9. They have to be different sets, and they can't be. If we had orange here. Yeah, this just breaks it. This has to be yellow. This would be green, and this would be pink. And then we have the same problem, right? Blue can't be that way. Blue can't be here. It cannot include at 9 period. Ugh. So how do we do that? Huh. Hmm. I don't see how you can get two verticals and two horizontal sets with this blue here. That's really the problem, right? I can get two horizontal and two vertical cages everywhere else. But assuming there's no overlap, and I'm pretty sure there can't be, these all have to be unique digits here. Ah, what is this? Um, you have to have the center box be one, but then that limits things a lot. Right? If it goes horizontal, that forces three horizontals to add up to 9 in box 9, which we know there are two horizontals and two verticals no matter what. The only way you fit two horizontals and two verticals is if you go this way. If you go around the center. But then the problem is that the blue doesn't work, right? This can't be blue because again, you have to have that set adding up to 9 here, but then this can no longer be two digits, two cells in cage adding up to 9. Unless 9 is not the solution, but that doesn't seem to make any sense, right? Yeah, these are two unique digits, two unique digits, two unique digits, two unique digits. But then the problem is, yeah, again, to have two horizontal cages adding up to 9 and two vertical cages adding up to 9, they all have to be unique digits. It can only go this way, this way, this way, and this way. Uh right, if we try going this way, there's only one vertical we can do. So it has to be that, then, like, say that's orange, this can't be yellow, that's pink, therefore this is yellow, this is green. But then this becomes a 9, and that fails because of the blue, right? And the problem is well, yeah, without rotations or reflections. Reflections, actually, we could potentially, well, that's kind of. It would make things problematic for trying to figure out where yellow and orange would have to be. But the problem is that we can't even get that with blue at all. Right? This is one way to get orange and green and pink and yellow here. That's the other way would have to be here, right? Orange. This can't be yellow, so this is yellow. This would be pink, and that would be green. But then again, this doesn't add up. This can't be blue. This can't be blue. That can't be blue because of the 9. Cannot be there. And this can't be blue because that, again, would have to be not 9. But it has to be 9. That's the problem. What am I missing? Hmm. This is problematic. I don't know. Hmm. This obviously can't be blue because these two add up to 9. These can't be blue because these two add up to 9. This can't be blue because this would be the 9. Oh, wait. X doesn't have to be 9. Okay. That's where it is. Yes. It has to be that way. And then it has to be one of those ways that I was talking about. It has to be either... So either this is... Orange is either here or here. Yellow cannot... So if orange is here... Yellow cannot be here. So yellow's either here or here. So if we go orange here, this would be... Okay, so let's do the possibilities. Right. X does not have to be 9. It does not have to be a single digit. That's one thing I forgot. If orange is here, yellow can't be any of these, so yellow has to be here, which makes green here and pink here. This cannot be any green, so this is the other digit. We don't know which one that is. Actually, we do know. This is the same as this. It has to be the same as that. Because it can't be orange, pink, blue, or green, or yellow. So dark has to be in one of these. So this cannot add up to 9. It could add up to 10. It could add up to 11. And there are distinctly 8 unique digits which add up to the sum. So it either does add up to 10 or it does add up to 11. So this is 1 or 5. And this will always be part of the blue. Interesting. So if orange is here, this is can't be yellow, so yellow has to be here. This is pink, that's green. If orange is here, yellow has to be here. This is pink. And this must be green then. So yeah, this is green or pink. This is green or pink. This is yellow, sorry, green or orange. This is yellow or pink. These are yellow or pink. This must be the same as this digit. And it adds up to either 10 or 11. If it's 10, then this must be a 5 here. Which means it would have to have 1 and 4 be here. Or 2 and 3. If it's 11, then this is 1. Okay. Okay, hold up. Where is the blue again? Let's do that. Let's remove all these. So we know... Okay, so blue cannot be here. What happens if we have blue here again? We know this is dark. This does not add up to X. So therefore, these two must add up to X. And therefore, this is orange. That makes this yellow. This green. And this pink. And... Okay. Seems reasonable. Then this would not be yellow, so that would be pink. This would not be green, therefore it's orange. Okay. Hmm. Um, it's not that helpful. Hmm. Okay. What happens if this is blue? Again, this is dark. This does not add up to X. So these two would have to add up to X. Cannot be yellow. They must be pink, which makes this orange, which makes that green, and this yellow. Okay. That means this can't be pink. That would be yellow. Ah, interesting. Okay. Since this is dark, this set cannot contain that cell. Well, again, it can only be here, here, or here, or here. So this must completely match this set. Okay. So we know these three are exactly the same as these three. Okay, let's mark them as A, B, and C. So this is A, B, and C there. We're guaranteed that. We don't know anything in relationship to that. We know one of these is the medium. Well, that's dark, I guess. Dark gray. Does that help? So these could be adding up. Well, one of these sets adds up to X, guaranteed. Right? So this is dark. We know this for certain. So we know this scenario. That's interesting. That means these five are exactly the same as these five. We just don't know which. Okay. Um. Hmm. Okay, so say we had orange here. That would force this to be yellow, this to be pink, and this to be green. We know this would not be green, so this would be orange, orange here, which means neither of these could be orange, so this would be green, green. So that matches that. This would be the yellow. This could not be yellow, so this would be pink. So this pink would have to appear here. Okay, that seems fine. And then we have one yellow and one pink here, which matches these. That seems fine. This is two green, so this is not green. That's orange. We don't know which one's which here, though. Okay. Does that tell us much? I don't really know. Blue. Okay, so if x is 10, we know x is 10 or 11 because 9 is already ruled out. So we're saying this is pink. So if this is pink, these are both pink. Which forces this not to be pink. This is yellow, which means... Oh, that's a problem. There's a contradiction there. Okay, so we try to have... This We try to have A and C be the correct pair. But it cannot be yellow because, again, these cannot be the same. And they would have to be the same because there's no reflection here. And obviously no rotation. So this would be pink, which would force both of these to be pink. But then that would eliminate pink in the rest of the box. So these are both yellow, which would force this to be pink. And we'd have 3 pinks in column 7, which is not allowed. So we know A and B are the pair here that adds up to X. And they must be orange. So this is orange, which means this can't be orange. This is green, which eliminates green in the rest of the column. So these are both orange. This has to be yellow, because yellow cannot be here. And to have 2 verticals and 2 horizontals, one of them is here, one of them is here. So this is green and this is pink. This double yellow means this can't be yellow. This is pink. This is yellow, guaranteed. So one of these is yellow, one of these is pink, which forces this to be yellow. And this must be C. Okay. So this C means this is C. Okay. A and B are here. This is A, that's B. Oh, okay. So this is both green. We have, this is pink and matches this one. I don't know which one it is. These are both green. These are both green. I guess this is D. We'll have E, F, G, H. Okay. Okay. This is A or B, we're not sure which. This is A or B, we're not sure which. So we know C cannot be here, cannot be here, cannot be here. So C is one of these two. C is one of these two. B is one of these 3. This is a GH pair. This is A or B, A or B. This is E or F. We don't know which one this is. This one cannot be that one. So this could actually be this one here then, now. Okay, so this is ABC matching this. This is either EB and dark. So this could be BE and dark. Or dark. It cannot be dark CD. That's not allowed. So it could be BE and dark. That's possible. It could be F, dark. Oops. Dark and G. So those are the possibilities. So it's either here adding up to X or here adding up to X. Okay. So this is G or H. We're going to mark this actually as Z. And that has to match Z there. Z is one of these 3. This must be vertical. And cannot have C. Cannot be A or B here. So it cannot be A or B. Cannot have C. Because this is C and this is Z. This cannot be Z. Because if it were part of box 9, then it would be, if it's the pink, it can't go in box 9. It can't be cloned. So this cannot be Z. So Z is in one of these cells here. Cannot be A, cannot be B, cannot be E or F because that's green here. So no C. So this cannot contain C, cannot contain A or B. So this cell specifically cannot be C, cannot be A or B, can't be E or F. It has to be dark. So this is dark here. And that must be with G. So this is G, which means this is pink. This cannot be Z. This is A, or this is Z, but it's H essentially. So this is H. This becomes G and D here. So this is a pair. Same with this. This can't be A, C. So it cannot be A or C. It technically could be D. It could be B. So you could have, okay, so what are the possible combinations to clone this? This would be B and E. Going that way. Cannot be A, cannot be C. It could be dark and F. It could be D and G. No, it cannot be D and G. Okay, so that's basic. Yeah, it cannot contain G or H because we have both pinks here. So it's either dark or B, or this is E and F. So this is guaranteed to be green. Okay. What about this red? Red has to be either A, C. So A and C, that's possible. B and dark. Or E and F. But if E and F are both here, that would eliminate green for any possibilities there. So this is AB, AC, or it's B and dark. We're not sure which. Okay. So with that set, this is set. We know blue is either... So this has to be dark, guaranteed. Right? Because it's either this one or it's this one. We know it can't be this one because these two already add up to X. And it can't be this because we need... Wait, why can't it be this? Oh, it might be able to be that. No. No, it can't. You are guaranteed... Right, because it cannot be the same as A, B, and C because that doesn't add up to X. So it can't be the same as that one. Therefore, it must always include the dark as a set. And again, it can't be C, D, and dark because this already adds up to X. So it's either this one or it's this one. Either way, dark is here, which means this cannot be dark. So this cannot be dark in B. Therefore, this is A and C here. Okay. So that matches this. So that's the correct clone there. A cannot be here. A cannot be here or here. So A is one of these two. C is there. C is here. C has to be one of those three. A cannot be here. A cannot be here. So where is A in box 4? It must be here. So that's A. B can't be here. B can't be here. Where's B in box 4? It has to be here. So this is A and B. Z has to be here, and it must be with H. So Z and H are in some relationship. We don't know which. None of these can be... This is an EF pair. Oh, this is G. Well, we already knew that. D and G. This is the remaining digits here. So D cannot be here either. Where is D then? Oh, wait. Okay, Z is H. That's what I was missing. So this is H and D. So this is a DH pair. Okay. So this is B. So this can no longer be B here. Which means this can't be B, so it's F, dark, and G. So this is F, that's dark. And this is G. So that's G, this is F. Dark is here, dark is here. Dark cannot be here, so dark is one of these two. Remaining digits here in row 5, we have D, E, F, and dark. This can't be D, so this is E or F. This is an EF pair here. Therefore, that eliminates E and F in the rest of the row. So this is D or dark here. So we're guaranteed D has to be one of these two. Remaining digits in row 4 are, this is C, no A, B, D, could be E, F, and G. G cannot be here, E, F cannot be here, so this is C or G, this is C, E, or F, this is E, F, or G. This can't be dark because of the dark here, so this must be D. So this is D, this cannot be D, and is dark. Dark cannot be here or here. Dark has to be one of these two. So dark is one of those two, we're not sure which. Okay, remaining digits in column 7. No A, we could have B, no C, D, could be E, F, G, and we're guaranteed a dark in one of these two spots. This cannot be F, this can't be G. Okay. Remaining digits in column 2. No ABC, so it's D. F cannot be D, E, F, and H. This obviously can't be F because of F in the box. This can't be E because of E in the row. D and H have some sort of pairing together. Remaining digits in column 8. We have, or remaining letters. I guess it's C, E, no D, F, or H. This can't be F. Remaining digits in column. So this is this one that matches. We have F, so this is blue. We don't know what that is. It's either B, that one, or that F. Okay, this is definitely dark. This is dark. Remaining digits in column 9, or letters, A, C, D, and G. This obviously can't be G because of G in the row. That's it, really. All right. Remaining digits in row 8. We have B, E, G and H. B, E, G, H. This can't be B or H because of the BH pair in the column. This can't be G here. Okay. Does that tell us anything? I'm not really sure if it does. G is one of these two. Huh. A has to be one of these three cells here. Uh, uh, hmm. Uh, hmm. 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 Okay, remaining digits in row 7. Cannot be dark here, but this could be D, F, G, and H. No G. D, F, and H then. G has to be one of these two cells here. We have D, F, G, and H. This can't be H because of H in the column. Any of these could be dark, though. Yeah, any of them could be dark. I guess I'll make this I. So this could be B or I. This is definitely I. So this could be I, this could be I here. So this is I. This is I. So this could be I here. So I has to be in column 3, one of those two. These could be I also. Hmm. Hmm. Uh, uh, C H has to be one of these three. C is one of those two. This is specifically just A, B, C, D, E, F, or I. Obviously, A and C cannot be here. B cannot be here. Oh, these cannot be D here because of the D in the box. So we know D has to be one of these three. I don't know if this is helpful. G is one of these two. Okay. Oh, wait. No, I have the coloring all wrong. Dang it. Ugh. Ah. Okay. Let me just restart this so that I can keep my brain on, yeah, figuring things out. This is yellow, green, orange, pink, and then blue. Marking this as red. These are all unique digits because they add up to X with another unique digit, and they have to be in some order. This is the digit that's not part of that, and it's 1 or 5. So this cannot contain that. To have 2 yellows, 2 oranges in horizontals, I think we tried this. If this is orange, that forces this to be... We know these are exactly the same. So this is A, B, C. A, B, and C. And we try to have A and... Right, A, B, C. A, B, C. We try to have A, C be the same. But then that would force us to be pink. It would make that pink. This is therefore yellow. But the problem is double pink here makes both of these yellows, and we'd have 3 yellows in row 4, which is not allowed. So these have to be the same. It has to be the orange. This is then yellow. This is pink here, and this is green, which forces this to be dark. So that's, yeah, that's the problem with that. So this has to be orange. These are both orange, which makes both of these green. Wait, didn't I already do this? Anyway, this is pink. This is a combination of yellow and pink. This must be pink, so this must be yellow and a C. Again, this is... We make this D. So this can't be C. This is D. That's C. We're making this E and F, G and H. And we'll make this I. This cannot have a green in it, so going down, it cannot have C, it cannot be I to G, cannot be F to H, cannot be A or B, so this has to be both pinks. Okay, that's where I think I messed up. So again, you can't have C here as the top one in this top row. So it can't be CD, cannot be IG because that requires a green, and this is a GH pair here. So this must be orange. This is A or B. A or B. This is G or H. So it can't be CD, can't be IG, can't be FH. Can't be AC because the A can't be here in the top. Can't be B, so this has to be E and F. Which makes this E, that's F. Which means this can't be F, that's E, which makes that E. So this must be a DF pair. Where are A and B in box 4? Cannot be here, so it has to be an AB pair here. This red has to appear somewhere here. Again, it cannot be I, C, and D because C and D already add up to X. So it has to be either this is B. So this is AB. And this is D and I have some relationship. Okay, so this could be, again, it must contain an I, so this is either I here, this is B, that's E, or this is I, F, and G. Cannot be ICD, cannot be ABC, because we know A and B already add up to X. So it has to be this or this. So we're guaranteed I here, so this cannot be I, therefore this is D. This is I, which makes that the dark. This is yellow. These are both orange. D cannot be here. This cannot be any of these, so it must be either here, here, or here. So it's either AC, AC. It could be, it cannot be B and I, because that would eliminate all possibilities for that. And it cannot, it could be EF, though. Ooh. That's interesting. Right, because we colored these all wrong here. This was pink. So that's the problem there. So this could be A or E, and that's C or F. Okay. A has to, well, we don't know. We know this is E or F here. No, this has to be E. So this is E and that's F, which means this can't be F. This is E, which makes this A, B, and I here. Okay. There we go. So this is blue. So that's helpful. This can't be B, so it must be A, which makes that B. This cannot be A, so this is E and F. So this matches the pinks. Okay. The remaining digits in column 2 then are G, H, and C. This can't be C though, so this is G or H, which means this has to be C here. So that's C and is yellow. Where is the C in row 9? Cannot be here because C's in the box. Can't be here or here because C's in the column, so this must be C here. Okay. This is A and B. This has to be in some setting. It cannot be A, cannot be C, so these are ruled out. It could be, cannot include E or F, so these are ruled out. So no A, no C, so this is either D and G, or this is G and H. So this is green no matter what. Okay. Remaining digits in row 8 are A, B, G, and H. Okay. This cannot be B because of B in the columns. Can't be A. This can't be B. Okay. Remaining digits in row 9. We have A, B, E, and I. This cannot be E or I because of the E in the box and the I in the column. So this is A or B. We have an AB pair in row 9, which eliminates A and B in the rest of the row. I don't know what I just did. Okay. So this cannot be A or B. It becomes an EI pair. E eliminates E here, so this is I, which makes this E. So this is E, which is pink. This is the dark. This can't be B because of B in the column, so this is A, which makes this B, which makes this A. Interesting. So this can no longer be A. This can't be B. This becomes a GH pair, which eliminates G and H in the rest of the row. So this can't be G or H. It's A, which makes this a B. So this is orange, orange, and these are both green. We need an I in box 7. It cannot be here, so it must be here. So this is I, which makes this a D. So this is D in yellow. That leaves this as G and H in F as possibilities. Okay. We have a DFGH quadruplet in column 4, which eliminates DFGH in the rest of the column. That leaves just B and I. This can't be B, so this must be I, which makes this B. So this is B, this is the dark. So that matches this. This matches here. E's here. That leaves this as C, D, G, and H, right? We are guaranteed H is one of these 3 cells because H cannot be here. We're actually guaranteed G has to be here, so this cannot be G. Where is B then in box 3? Can't be here, can't be here, can't be here, can't be here, so it must be here. So this is B. Remaining digits in column 7 are no A through E, so it's F, G, H, and I. This can't be F or I. This can't be I. This can't be I. Where is the I in column 7? It has to be here. So this is I. This is F, G, or H. Remaining digits in box 6, we have C, D, F, G, H. F and H cannot be here. C cannot be here. F cannot be here. D cannot be either of these. G can't be either of those. Okay. Remaining digits in... We need... Remaining digits in column 1. We can have A, no B, C. Could be D, no E, F. It's G or H. A cannot be here because of A in the row. G cannot be here because one of these is guaranteed to be G. Because again, this can't be A, B. This can't be C, I. Cannot be B, E, or I, F because of the pinks here. So this is G. Remaining digits in letters in column 3. No A, B, C, D. So it's F, G, and H here. Where is E in row 3? Can't be here because of the E in this box. Can't be here because of the 3E in that box. Can't be here because of E in the column. So this is E here. And it's pink. What is this? C, D, no E, F, G, or H. Cannot be F or H because of FH in the column. So we have all the E's. We should have all the I's. We have 8 I's, so we need the last one, which means it's here. So that's I. GH is in a ratio. Guaranteed. And they add up to X. Say you had a 10. If you had 10, you would either have to be consecutive, which is not possible to add up to 10, right? Because it would be an odd and even digit, or 1 to 2 ratio, which is not possible. So that means it must add up to 11, and I is 1. Since I is 1, that means F and or B and E add up to 1 is only in a 1 to 2 ratio or consecutive with D. So D has to be 2. So these are all 2s, which makes C's 9. So C's are 9. 2 and 9 add up to 11. That means these are consecutive. So it must be a 5-6 pair for G and H. So the remaining digits then are 3 and 7 to add up to 11. So B and E are 3 and 7. Okay. You know G and H are in a ratio. So this is 5 and 6. B and E are then 3 and 7. Okay. 3 go so 3 and 7 add up with 4 and 8 to 11. So all the A's are 4 and 8 and all the F's are 4 and 8. Okay. This cannot be 3 and 7. So what are the remaining digits? 4, 5, or 8? Well, we're guaranteed we got all the ones. Do we have all the twos? We do not. So it's either 4 and 5 or it's 4 and 8 here. So this cannot be 4. It's 5 or 8 here. Okay. So we have, again, 9, 2 here, 9, 2 here. This is 1, 3, 7. Three, 7, 3, 7 is a pair here. So this cannot be F. Which means where is the F? Oh, wait, no, this could be F. Dang it, okay. Let's go back to the... Okay, so... Okay. Actually, yeah, let's do E's. So we'll make that. That has to be 3, 7. And B's, we'll make that also 3, 7. We'll keep the A's and the F's for now. So this has to be B. It's 3, 7. Okay, so we got 1, 3, 7 matching that. This could be 2. So this becomes a 2, 8 pair. Oh. No, 2, 4, 8 pair. Right. Yeah. We have again, so this is 4, 5, and 8 remaining. And 4 can be in a ratio with 5 or 8. So this can't be 4 then. Which means 4 in it could be a fudge. Hmm. Okay, so these are all pink. I think I deleted the coloring there accidentally. So this is guaranteed 4. So A or F? Oh, interesting. A or F is the 4 and 8 possibilities. So 4 has to be one of those two here. Where is the 4 then in row 1? 4 has to be one of these two cells then. Okay. So, what are the possibilities in column 3? We already have a 3-7 pair. We have 1, 2, and 9. So that leaves 4, 5, 6, and 8. And this cannot be 4 because we're guaranteed a 4 has to be one of these two to be in the 1-to-2 ratio with 8 or to be consecutive with 5. Does that tell us anything? I don't really know. Where's A in... Aha. Where is A in box 3? Cannot be here, cannot be here, cannot be here, so this must be A here. Which means A cannot be here, so this is guaranteed to be A here. Okay, and this could be 4. Oh, A cannot be here, and this is guaranteed to be 4 here. So therefore, A must be 8. So A's 8, and then orange must be 3. Which means this is 3. Pink 3, 7. Has to be 7. Which means F has to be 4. So that means 4 cannot be here. So 4 has to be here. This must be 4. Because there's no other place for 4 in row 1. 4 is one of these with 5 and 6. So this cannot be 8 because of 8 in the box. So this is 5, which makes this 8. Ooh, we have a contradiction. That's not good. It's too many things going on now. I think I need to restart again. Ah, this is so bad. I'm doing such a poor job here. Okay. Because I try to translate stuff and it's just getting confusing for me now. So this is A, B. which matches this. A and B, that's C. This is C, C and D, C and D. Both yellow. This is dark, which makes that. This is pink to be up. This is green. We have E and F, G and H. We don't know which ones those are. This has to be A and B specifically. This one are 5, and this is I. Okay, so this matches here. A, B, C, A, B, C, C, D, C, D. A, B matches A, B. This is E and F, matching E and F. This has to be G and H. Okay, that's another thing that we... Okay. We needed to match there. That had to be the case there. So then this cannot be yellow. This has to be pink. So these are both orange. This can't be green, so this has to be orange. These have to both be green because it can't be orange here. Therefore, that must be orange there. This is yellow. This can't be yellow because of the double yellows here, so this is pink, which makes this yellow and pink as a pair. This is pink here, which makes this yellow here and a C. This must be a pair, cannot be AC, cannot be BI, cannot be C, D, because it can't have a C, because of the C has to be here. So no AC, no CD, no BI, cannot be IG, cannot be FH, it has to be E and F. So this is E and F. Where are the A and B in row 4? Row 5, it has to be here. So this becomes an AB pair. This is a DI pair. Again, this can't be ABC because we know A and B already add up to X. Can't be CID for the same reason because C and D already add up to X. So it's either BEI or IFG. So this is either BEI. And it cannot be IFG, so this is B, E, and I. Okay, so this is pink. Let's use the original coloring because otherwise I'm getting confused that way. That means this can't be I, so this is D here. This is I. This can't be B, so this is A and B. So these are both orange. This is yellow, and this is dark. Therefore, to be here, it cannot have C, I, or F. It's either A, C, B, I, or E, F. And we can't have A or B here, so this must be E and F. So this is E and F. Oops. E and F. Both pink, which forces this to be a C here, and is yellow. Remaining, this digit is remaining. We don't have a C and we don't have a G. C can't be here because of C in the row, so this is G. This is then C and yellow. Okay. This can't be F, it's E, which means this has to be E also. This becomes a GH pair here. This is A or B, A or B. This is D or F. Remaining digits again in row 8. We have A, B, G, and H. Okay. This can't be G. This can't be G. This can't be B because of the B in the column. This can't be A. This can't be B. G has to be one of these two. To form a pair here, you cannot have A starting here or C, so no AB, no CI. You cannot have BE or IF because we have an E and F already in the box. So we know no AB, no CI, no BI, no IF. So this is either DG or GH. We're not sure which, with a guaranteed G there. This is always going to be green then. Remaining digits in row, letters in row 9, A, B, no C, no D, E, and I. I cannot be here, so neither can B. This can't be A, this can't be B or E, so that's A or I here. This is B, E, or I here. Remaining digits in row 7. No A, B, C. Could be D, no E, F, no G, H, or I. No F here because of the F in the column. This can't be I. Where is the I in box 7? Cannot be here, cannot be here. This must be I here. That means this can't be I here. I don't know how we got, anyways, whatever. Okay. Remaining digits in column 1. A, B, no C, D, or H. No B because we have 3 B's here, so therefore this must be B here. Which means this cannot be B here. G is guaranteed to be one of these two. This can't be F because of F in the box. This E eliminates E here. Oh, that's why. So that's A, this is B, this is I, this is E. This B forces this to be A here, so this cannot be A here. We have A, D, H here, so this must be F and G. And this can't be G because of G in the row, so this must be F, which makes this G, which makes this. This A eliminates A here, so it's H, which makes this D, so this cannot be D. This can't be H, this is G, this is A. This G eliminates G here, so this is D, which makes that G. This can no longer be D. Remaining digits, this D eliminates D here, so this is F and D. F eliminates F here, so it's H and F. Okay, so this is the non-yellow, this is non-pink. Okay. Remaining digits in column 4, we have B and I, but B cannot be here, so this is I, and this is B. Remaining digits in column 5, we have A, B, C, and H. So this is a CH pair. So G and H, again, are in some relationship. Obviously, it cannot be... cannot be in a 1-to-2 ratio with 10, cannot be consecutive with 10, so therefore X must be 11. So since X is 11, that means these are 2 through 9 here, which forces all the I's to be 1. I cannot be here or here. Remaining digits in row 5, we have no ABC, so D, G, H, and I. D cannot be here. This can't be G or I. This can't be H. Okay. One's only in a 1-to-2 ratio with 2, or consecutive with 2. So this is 2, which makes C a 9. Okay, so we have 2s and 9s. We know H and F are 4 and 6s. Sorry, 5 and 6s. Okay, remaining digits in row 1. We have A, B, 1, E, F, G, H. Okay. No E, F, G. So 1 with A, B. So this can't be 1A or B, so this is an H, which makes this a D. That H makes this an A, so this can't be A or H. This can't be A or H. It's 1 or B here, 1 or B here. This B eliminates B here. So this is 1, which makes this B. A cannot be here. This 1 eliminates 1 here, so this must be 1 here. So we have all the 1s then. This cannot be D or I, so this is G, which makes this H, which makes that G. Okay. We have 2G, that's fine. D is 2. So this is 2. We have B and E. Both must add up with 1 to add up to 11. So that makes it 3 and 7. So this cannot have 3 and 7 here. It's 4, 5, 6, and 8. Huh. We have a guaranteed 9 somewhere here, so 9 has to be one of these two. C is one of these as a 9. H cannot be here. H cannot be either of these, so this must be H here, which makes that a green. So this cannot be... So 5 or 6 could be one of these still. It's G with F. Yeah, I think it's G and F. So 1 of 5 or 6. And then F is 4 or 8. Well, if G is... Okay, so this can't be G. So this must be a G here. Which makes it 5 or 6. So this cannot be 5 or 6. This is the F. So this becomes F. This is G. And G is 5 or 6. 6 is not in a consecutive ratio, consecutive set, or in a 1 to 2 ratio with 4 or 8. So that means G has to be 5. And therefore, F must be 4. So since F is 4, E must be 7 to add up to 11 with it. B has to be 3, which means A has to be 8. Therefore, H is 6. And here we have a 4-9 pair. This can't be 4, so this must be 9, which makes this 4. H is... What was H again? 6. So this has to be... This becomes a 2-6 pair. This becomes a 9-6 pair, I believe. 8 cannot be here. 8 cannot be here, so 8 is here. We have 2, 6, and 9 remaining, and this can't be 2 or 6, so this must be 9, which makes this 6, which makes this 9. That makes this 2 and 6. 2 can no longer be here, so this is 2, and that's 7. Oh, that took a long time for me to figure that out. I think it's because I got stuck on this thinking that X had to be 9. I think I'm so used to having X being a single digit, so I just assumed that X had to be a 9. Had to be a single digit, but it was actually double digits. That took a while. Yeah, and then I kept on messing these coloring things up. Yeah, I should have just basically kept the same digits throughout, if possible. So let's see the cages. 371, 371, 25, 25, 74, 74, 74, 74, 74, 74, 5, 6, 5, 6, 8, 3, and 9, 8, 3, and 9, 8, 3, 8, 3, 9, 2, 9, 2. I think it's hard. I don't think it's challenging. I think this is actually a hard puzzle. It's not very hard. The logic behind it is sound. I just got stuck with the X because I just kept thinking of a single digit there instead of actually realizing X could be any number. Um, yeah. I don't know. I'm not yeah. And then I kept on messing up other spots here. Not quite sure what. One thing I should have been able to figure out almost immediately, though, was that I kept on not thinking that, not really comprehending how these had to relate to these. And also, I messed this up where I had that as green. I don't know. I just made a lot of errors here. Um, but I hope you enjoyed this solve, either way. And I'll see you next time on Frank Puzzles. Take care.